right, good afternoon or evening, or for some of you who are doing these at midnight and after, good morning, I guess. Um, we're going to be talking today about how atoms differ from each other. This is section 4.3. Make sure before you get started you have your notebook with you and a pen so you can or a pencil so you can take notes on this section. Also make sure that you have read this section, okay? All right, so let's talk about atoms. Okay, first of all, the atomic number. This is the number of protons in an atom. And since we know that atoms are neutral, if it has a certain number of protons, that also has to be the number of electrons um, in the atom. So the atomic number is the number of protons. So if we look here, this is how we would see hydrogen listed on a periodic table. First, you give the chemical name, hydrogen. You give the atomic number, which in this case for hydrogen is 1. The chemical symbol is H for hydrogen, and then the average atomic mass. Hydrogen atom only has one proton and one electron. It doesn't have any neutrons. The average atomic mass is the number of neutrons and protons, so it's everything that's inside the nucleus. Okay, isotopes. Isotopes with the same number have the same number of protons but different numbers of neutrons. Okay, so atoms with the same number of protons but different numbers of neutrons are called isotopes. Isotopes containing more neutrons have a greater mass, obviously, because neutrons weigh about the same as a proton. The relative abundance of each isotope is usually constant. So what does that mean? That means that if you're talking about potassium, the number of the percentage of potassium ions will be the same in a banana as it is in the the dirt. Okay, the percentage of isotopes remains the same regardless of what you find the potassium in. Isotopes have the same chemical behavior. So just changing the number of neutrons does not change the behavior of um, the atom, because chemical behavior is determined by electrons. The mass number is the number of protons and the number of neutrons in the nucleus. So the mass number is the atomic number plus the number of neutrons, because the atomic number is the number of protons. So we have protons plus neutrons gives you the mass number. And remember, that's going to change when we talk about isotopes. The number of neutrons will change. Okay, so isotopes of potassium. All right, we have potassium 39, potassium 40, and potassium 41. If you look here, the number of protons remains the same in potassium 39, potassium 40, and potassium 41. There are 19 protons in all three of these. If you look at the number of electrons, it is also the same in all three isotopes. We remember that the number of protons we have has to be equal to the number of electrons. So 19 protons, 19 electrons in all three isotopes. If you look at the drawings down at the bottom, you'll see where they're showing the nucleus there from the center, and then the electron cloud all around the outside. But the number of neutrons will change. In potassium 39, there are 20. So 19 plus 20 will give us 39, hence the name potassium 39. The same thing for potassium 40 and potassium 41. The number of neutrons will go up. So for potassium 40, it's 21. 19 plus 21 gives you 40. And for potassium 41, 19 plus 22 gives you 41. So the number after potassium in each of these is the atomic mass, which is the protons plus the neutrons. Okay. If you look down at the bottom, you'll see the letter K. Okay, that's the periodic table notification. The atomic name for potassium is K, and you'll see that there's two numbers there, 19 which is the atomic number, and 39 for the first one. So when you're writing isotopes in the symbol form, you'll write the letter, so K for potassium, and then the atomic number in the bottom and the atomic mass in the top. Okay, so from looking at this, potassium with a 19 and a 39, we can tell that there is a total of protons and neutrons together of 39. And so you can also figure out how many protons are there. So 39 minus 19 gives us 20. We know that potassium 39 has 20 neutrons. Okay, so here you see potassium 39 with 20 neutrons. Okay, 19 plus 20 is 39. 19 plus 21 gives you 40. And 19 plus 22 gives you 41. All right. All right. Talking about the atomic mass unit. One atomic mass unit, one AMU, is defined as 1/12 the mass of a carbon-12 atom. As we go through chemistry, you'll find that lots and lots of things that we talk about, their units are based on something having to do with chemistry. Having to do with carbon. When we talk about moles and stoichiometry, this will come up again. So one AMU, one atomic mass unit, is nearly but not exactly equal to one proton or one neutron. So one atomic mass unit is pretty close to the AMU for a proton, which is 1.007276, or the atomic mass unit of a neutron, which is 1.008665. Remember that electrons are considerably smaller, so their atomic mass unit is 5.49 times 10 to the negative 1, 2, 3, 4. Okay? All right. Now, one slight thing that I want to point out before you point it out to me. Okay, if they say that one atomic mass unit, one AMU, is defined as 1/112th the mass of a carbon atom, and you look up the mass of a carbon atom and divide that by 12, you're not going to get exactly this number. You're going to get a number that's smaller than that. I'm aware of that, and I am trying to figure out exactly how to clarify that for you. So don't worry. Okay, we'll work on that together. All right, so just to review again, when you look at something on on a periodic table, you'll have the chemical name, the atomic number, which is the number of protons, the chemical symbol, which is usually one or two letters. There are a few that are three. The first letter is capitalized, the second or third letter will be lowercase, and the average atomic mass, which is the combination of protons and neutrons. So everything in the nucleus will be the average atomic mass. All right, so if we're talking more about isotopes, we're going to calculate the weighted average of the atomic mass of chlorine. So what we're talking about is if you have chlorine, but then you have isotopes of that chlorine, the atomic mass of an element is the weighted average mass of the isotopes of that element. So it takes into account that you have a certain percentage of an isotope. And so you can't just have one atomic mass for all of, let's say, chlorine. That's what we're looking at here, because you have the regular chlorine and then you have the isotopes of chlorine. Okay, so if we look here at chlorine 35 and chlorine 37, okay, chlorine 35 is going to have 17 protons and 17 electrons, but it's going to have 18 neutrons. Okay, chlorine 37 will have 17 electrons and 17 protons. Remember, it has to have the 17 protons and the 17 electrons to make it chlorine, but it's going to have 37 neutrons. I'm sorry, it's going to have 20 neutrons. Okay, 17 plus 20 is 37. Okay, the atomic mass of chlorine 35 is 30. 24.969, so pretty close to 35. The percent abundance, this exists 75.78% of the time. So the majority of chlorine that's out there is chlorine 35. Okay, so if you say, I'm sorry, let's look then at chlorine 37. Okay, the atomic mass is 36.966. And the percent abundance is 24.72%. So it takes up the rest of the percent. So by looking at the math here, if we say 34.969 AMUs, atomic mass units, times 75.78%, which we would put in as just 0.7578, we would get 26.499 AMUs. Okay. If we did 36.966, the mass of chlorine 37, times 0.2422 or 24.22%, excuse me, we end up with 8.9531 AMUs. Okay, so then the weighted average atomic mass of chlorine is 26.496 AMUs from the first equation, plus the 8.9587 AMUs from the second equation, and what we come up with is 35.453 AMUs. This is the average atomic mass calculated based on how much of each isotope we have. Okay? If this is a little confusing, don't worry, we're going to be going into it a little bit more in class. Okay? The atomic mass of an element is the weighted average mass of the isotope of that element. So we take into account the average of each isotope that occurs within nature. All right, an unknown element has 19 protons, 19 electrons, and 3 isotopes with 20, 21, and 22 neutrons. What is the element's atomic number? All right, so think about this. The atomic number is what? The atomic number is the number of protons that something has. So if we have an element with 19 protons and 19 electrons, and it has 3 isotopes with 20, 21, and 22 neutrons, what is the element's atomic number? All right, I'm going to show you this quick video where they go through and kind of show the equation that we just did again. And then tomorrow in class, this is figuring out the average atomic mass of magnesium. Tomorrow in class, we will go into one where you're given the atomic mass and you have to figure out the percentages. All right, so
how do you calculate the average atomic mass of an atom if you're given the isotopic abundances and the mass of each of the isotopes? For example, magnesium exists in 3 different isotopes. Magnesium 24, which has this mass and is 78.7% of all magnesium found in nature. Magnesium 25, which has this mass and is 10.13% of all magnesium found in nature. And magnesium 26, which has this mass and is 11.17% of all magnesium. If you're given all the masses and given all the abundances, it's one of the easiest questions in the world. All you need to do to find the average atomic mass is multiply each of the masses, for example 23.985, by each of the isotopic abundances. Make sure you write your percentages as decimals, 78.7% being 0.7870. Then you just add on one of the other masses, 24.985 times its isotopic abundance, 10.13%. And you have to add the third isotope. Now some atoms have up to like 9 stable isotopes, so you may have to do this like a bunch of times. I obviously picked a simple example because I could. Then you just whip out your calculator and you plug these numbers in. 23.985 985 times 0.7870 plus 24.985 times 0.1013, and you add 25.983 times 0.1117, the other isotopic abundance. And you add all those together, you end up with 24.309. Now, it's average atomic mass. Your units are probably AMU. Your teacher may also just write that as U. I prefer AMU though. And that's your average atomic mass. What you'll notice is that if you get out a periodic table, oh look, the molar mass of magnesium is 24.30 something. Oh look, we got the number on the periodic table as our answer because the periodic table lists the average atomic mass for each of the atoms, so you can check your work. Best of luck in trying your own calculation.
We're going to be doing some of those problems in class. I'm also going to be giving you a list of all the isotopes and let you come up with some problems to do for people in class. So make sure that you have finished this video and all the questions, and I'll see you in class tomorrow.